Okay, we might just think about getting started. Welcome to our career seminar. It's really exciting to see a whole different range of people. It's part of the young 2018 Young Statistician Networking events. Firstly, I just would like to acknowledge this meeting is being held on the traditional lands of the Turrbal people, and I'd like to pay my respect to elders both past and present. A little bit of housekeeping. Emergency exits on the immediate left of the lecture theatre. Toilets are located on the right towards the lifts. So tonight we're really talking about careers in data. In 2009, Val Halloran, Google's chief economist, said that the statistician will be the sexiest job in the next 10 years. And really, I have seen that be true. He has basically said it's about harnessing supply and demand. Data is cheap, but what is scarce is the ability to utilise and analyse the data. So in the last 10 years, we've seen an explosion of data collection, and the opportunity that's come with it has been huge. But with this opportunity comes responsibility. It's really important that we interpret this data with integrity. But we also need to realise we need the skills to understand the limitations of the data, how it was collected, and did you do an RCT, meaning did you design this experiment where you can make causative conclusions, or is this an association? It's really important that you make a conclusion that's based on your data. And to help do this, the Stats Society provides accreditation for graduates and also for statisticians. So I'm an accredited statistician. I came up through the path of, I did an ecology degree and I worked as a consulting statistician. So getting a GStat allowed me to sell myself as a qualified graduate statistician. This gives your employers confidence that you have the skills you say you do. So it's always a good idea to join a society such as the Stats Society. But also in that, it also provides networking events like this one, but it also provides a community. I think that what's important is you come together and talk to other people that is excited about data as I am. So today we have 6 speakers. Well, actually we have 5. So unfortunately, the GAMOS speaker, Isaac, he came down with a virus. So unfortunately, we won't be hearing from him. But we have 5 other speakers with us today, and we will be having speakers that will be 10 to 15 minutes in duration. Please think about the questions you want to ask to the end, and we're going to have a 20-minute Q&A session. First speaker today will be Nigel from the Queensland Stats Society. We'll also hear from Professor Mark Chatfield and Susannah Leahy from Queensland Government. Sorry for that. And we'll be hearing from Dan from CSIRO. So thank you for the first speaker. He is a data analyst working from Queensland Law Society for the past 3 years. He has been unlocking data for the legal profession to help increase understandings of Queensland regulatory law. He holds an accounting degree and science and genetics, has over 15 years of experience in finance and data across business, government, and not-for-profit industries. Thank you.
That's me. I do stats. I am a data analyst. You probably assume I do work with data. I had trouble finding a photo, so was me from Parkrun just last week, looking very pained. A lot of the stats I do, being open and honest with you, is probably things you learned in grade 10, or you should have learned in grade 10, because a lot of it's not complicated, but the great thing about that is most people don't retain a lot of that knowledge, so you are the conduit to that, to everybody else. I will talk about some of the tools I've worked in, some of the projects, and maybe some of the important lessons I've got out of working with data for this long. I started off my career as a financial analyst, working as an investment analyst, mostly measuring volatility of returns, because normally the more volatile something is, the better the return is, on average. And we put people into portfolios, moderate, balanced, and high risk. The different asset classes, such as international equity, Australian equity, fixed incomes, things like that. The best thing about working with financial data is it's incredibly clean data. It's coming straight off the market. It's got tens of thousands of eyes watching it all the time. It's very little cleaning. The other joy is anytime you get company financial data, someone's entered into the system, a manager's checked it off, someone in finance has checked it off, CFO's checked it off, the CEO's signed off it, and they make sure it's clean because of the threat of jail time hanging over their heads. So they really do care about the quality of the data they're providing you. So that's the best part. Now, most of the systems I actually work on were just bespoke finance systems that are made. I don't have to do anything. Work with the St. George investment analysis system, work with the AVO finance system, and Excel. I know a lot of people aren't fans of Excel. There's good reasons not to be fans of Excel, but it is the most common data tool out there. It's one of the ones that you can actually pass around your organization. I have different systems at work, but if I need to pass something to a manager or higher up the chain, it always goes into an Excel format because that's what they have, that's what they understand. That's it. The other joys of working with financial analysts is you get a really high compensation. It is incredibly nice. There are many perks, like you get invited to so many breakfasts and lunches to get great speakers, and you get a half-an-hour product push, good meals all the time. If you want to work 70+ hours a week, like I did, it's brilliant fun at the time. My boss I drank a lot of Coke, probably about 6 cans a day, now down to about 3, so it's not really a problem. But my boss had a fridge full of my Coke. It was continually filled all the time. We had beer fridges, we had coffee machines, we had fresh food, we had cereals, milk, coffees, all those provided. Anything to keep me at my desk longer, working harder, will be provided. And we also got loads of free lunches and things like that. One thing I did learn though is people love numbers. It's saying something like we had more people here tonight than we did in the event last year is good. Saying something we had 15 more people come tonight than we did last year is even better because it's a quantifiable number. People like saying that. Saying we had 30% more attendees tonight than we did last year is even better again. People love those. People can actually, especially managers, something quantifiable they can take away and report to somebody else. Something they can say. Not just more, 15, but 30% shows that it was a lot bigger than last year. And that's really exciting. One of the examples that we'll talk about though is with each portfolio you actually have an average return. So we calculate its average based on previous history, past history is no indication of future history. And one of our advisors went, well, I have a balanced client, and what I'm going to do is I'm going to put them in a high growth portfolio because it's a nice return, and then put a large chunk of their money in cash and fixed income to bring down the average, which is perfect sense because they worked it out and they got the average return the same. But what it does is it actually increased the standard deviation of the portfolio returns because when you talk about volatility, this isn't something the financial advisors think about because they're looking at the one number, the average number. But knowing how maths works and how statistics works, I could draw these lovely little graphs on here's the up and down and here's what you've done with a really wide thing. To explain why what he was doing wasn't the smartest idea. The next thing that I realized where stats came in very handy was I worked just before I started this job, probably about a year or two before the GFC, which was great. And during the GFC, our portfolio, I worked with some incredibly smart people. There was a lot of incredibly smart people in a lot of finance. It pays. And they actually, our portfolios made a lot of money during that GFC period. We didn't go backwards at all. The downside of that is when the market did rebound, we didn't catch the rebound. our portfolios kept returning, but we didn't catch the rebound. So people, when they invest with you, want you to avoid every bear market, every downturn, but ride every upturn. If you could, I wouldn't be speaking to you today. I'd be Skyping in from my private island in the Cayman Islands. Because if you can do that well for a long time, you'll be copied and other people would start doing it too. So what we did was just simple examples that if you give me $1,000 and I return 5% this year, 5% next year, you've got a nice return, just over 110, which is a better return than what people did during the GFC, where they lost 30% and then they got 50% return. It's only $105. Simple maths, it's easy to explain, but trying to get that through to the common person going, you don't add 5 and 5, or minus 30 plus 20, 20 is better than 10. You have to show that. And that's what I really found I was good at. Just explaining, it's not a hard concept, but it's to a lot of people out there, it's difficult to, because 30 minus 30 plus 20, 50 plus 20, well, 5 and 5 is okay. And that's where I start to realize that even though people love numbers, most of them actually don't understand that much about them. So I left that job after I had a child, and I actually wanted to be a father for a period of time and see them occasionally. And I joined the government, and that's where I found working with data in the real world, which is working with messy data. You may have heard the old saying that data scientists spending 80% of their time cleaning data and the other 20% of the time complaining about spending 80% of their time cleaning data. It is true. So I also finally found art. It was brilliant. I would praise it forevermore. It's reproducibility. I'm really sorry, all you probably have worked on it for many years. I didn't, and it was great. And I was actually at the art conference where they were quite happy to slag off MS Excel, but I'm still a fan of Excel for many reasons. I actually did a report. I had to grab those. I couldn't find the old report about social housing data. And I actually had similar plots to those. You would have seen the box plot. I'm hoping as a statistician, you would have seen the box plot and a mosaic plot. Wrote up my report. I had similar plots in my report. Gave it to a co-worker to read. And they said, yeah, it's great. What are these? It's a box plot. It's a mosaic plot. They're really simple to read and understand. I explained it to them and went, oh my Lord, that's really great. And I went, great. Went to my manager. Manager went, love your report. What are these? Box plot, mosaic plot. Here's how you read them. And they went, oh yeah, that makes perfect sense. Went to my director. My director went, it's story. And before my director flicked it onto the DGG, I actually walked into her office and went, before you start, here's how you read these plots. And then took them out of the report because I wasn't going to go around, and I couldn't go around to the other 150 people who would actually see the report. So you understand them. They make perfect sense to you guys. They should hopefully make perfect sense to you guys. That's just from the car data, and that's from the Titanic data, if you've seen it on Google. That's where I got those ones. So it's about knowing your audience. So even knowing these things, and it's good to have that knowledge in the background, but I would never put them in another report again. I do them still when I want to know things, when I'm looking at data and playing around with it, but I don't pass them off the chat. There's just no point. That's where I've learned that people love numbers, but they actually probably don't understand how mathematics work. My current role at Queensland Law Society, I am in charge of all data queries, all ad hoc queries, and probably my favourite query I've ever received from a general manager. I will recite the whole email to you now, if you can at the time. It's a, hi Nigel, can I have some stats for North Queensland? And that was the end of the email. I am comfortable in my job. I was having a bad day, and my response was, since we work for the Law Association, I'm presuming you want legal stats. There are no Chief Justices north of Cairns. Please come see me. I wouldn't recommend that early on in your career. It's not the smartest move. Simple things that, and I learned one important question from that, and I hope you'll take away when someone asks you for data when you're working is, what do you want these stats for? What do you want these numbers for? Because what they want it for really determines what you're going to give them. And first of all, I didn't know, what do you mean by North Queensland? So if you're from Townsville, you think you're in North Queensland. If you're from Cairns, you think Townsville isn't North Queensland. And that's the way it goes. So I need to just get a general, just what you need the data for. One of the examples, questions I get asked regularly is, how many lawyers are there in Queensland? When they need it for a speech, I go, over 11,000, over 11,500. That's what you write in the speech. When finance asks me, because they need to match up money that we're going to send over to somebody else for their registration of lawyer fees, I go, here's the total number. Here's how many are volunteer PCs that don't pay. Here's how many are international PCs that don't pay. Here's how many at 1 level. Here's how much at 2 level. Here's the money you have to give out. And it's an exact number written to a date, as of this date, for different purposes. And so they're the same query, but the major thing is, what do you want this data for? If I tell you it's 11,695, no one's going to write that in a speech, and they're not going to say it in a speech either. The next big issue we have in law is there is still a gender imbalance. There's actually more male lawyers than female lawyers in Queensland at this current time. On February the 20th this year, there was actually more females, but that changed again in early July. The other big issue is, even though there's more males and females in law, one of the big issues we have is more females leave the profession than males every year as well. And this was something that was noticed before I joined Queensland Law Society, and it's something they're working towards to try and rectify. So I'll get back to that when I just have a quick chat about the machine learning we did. So we are a member organisation as well. We have approximately 12,000 members. I don't like using that number because I don't think it's a real number, but it's what the stats say. So I will use it for the speech. So what we can do is we have about 98% of people renew their membership and 2% don't, of our major group of full members, which is about 10,000. So I thought, you know what, we can't call every member and tell them we love you, please renew your membership, because we just don't have the resources for that. But hopefully I could use some machine learning to try and figure out who aren't going to renew. And so we went on to Gaggle, the Titanic problem, went on to GitHub, stole someone's code, borrowed someone's code, pumped into R, changed some variables around. And what came out is gender wasn't important. And what the issue was about young people leaving the profession, volunteers, there was a whole lot of other things, but gender wasn't one of the things that determined if you were going to leave the profession. It just blew me away, especially knowing what I just knew about how many females were leaving the profession every year. So I did a bit of investigating. And what we found is we have 1,000 new lawyers join the profession every year, of which 60 to 65% are female. So the pipeline of females coming into the profession is quite large. So 40% of lawyers have left within 5 years. So that's where everyone's leaving. They're not leaving because they're female, they're leaving because they're new. They just happen to be female in that group. So the reason they're leaving is not being female, they're leaving because they're new. It's a whole different way of looking at that second dot point. And that's why every year from now on in, as more people join, we will have more females for the second half of the year until the balance finally kicks over at renewal period. Right now, with all the talk of social media and how great social media is, and Twitter and Facebook and Instagram and LinkedIn, my organisation is on all of those. You're welcome to follow them. We do some important stuff, and some stories grab a lot of traction, especially ones that involve murder. They seem to really get the eyeballs on for some reason. But we found that emails is actually the best way of getting people to our events. We run 180 events a year, and we need to get people on. We have all the email addresses of lawyers because we need to contact them for regulatory reasons, and it's a requirement they provide it to us, and we're allowed to use that data. So I do a lot of A/B testing with emails, seeing what's statistically significant, and mainly subject line optimization. Things we have found is if I have a really broad subject line, more people open it, few people click. If I have a really specific subject line, less people open it, more people click on it and go through to the event. It's simple things. Other things we do is something new I found out only last week, is if you put an emoji in the subject line, no one in government will open the email. It's unprofessional. However, all the people from the large law firms, especially old men, love it. I will just say the sample size of government people was 32. So I won't base all our work on that yet, but we're going to try it again. That was something interesting to find out. Students are really bad at opening emails as well. You people are crap. We have like less than 10% from you. Not from you, I'm sure you will all, if you ever received an email from the Law Society, would love to open it and read about that events. Okay. I guess the main takeaway points that I have is when you get asked for data and get asked to do statistical analysis work within, my main first question is, what do you want the data for? Because knowing that, what they ask you is quite often not what they want. Because they've got preconceived ideas, and you can give them actually useful information that helps them. The other main thing is people really do love numbers. They, as I said, they want quantifiable numbers. They understand it to a degree, but they don't understand your statistics. They just don't understand statistics. Another stat that came out that I read in a report is we have a specialist accreditation. The average age increased, I think, by 60% of the graduates of that course in 2 years, which blew me away, which was just, that's a really interesting stat. Till I went and pulled the raw numbers. And 2 years ago, we had two 30-year-olds graduate from the course, and this year we had a 50-year-old graduate from the course. So the 60% is quite correct, just not really a useful number, but it's what they've done and put in the report. Systems and programs that I use, as I said, I'm a big fan of Excel, big fan of R, most of them bespoke. It doesn't really matter. I found they may say you need it. You can always learn on the job. And training will be provided. I work with a lot of databases, most of them are SQL based. Doesn't matter what the front end is, as long as you can get access to the back end, because that's where the real data is in the tables. And that's me. Thank you.
Our second speaker tonight will be Mark Chatfield from UQ. Mark collaborates and consults researchers in the Faculty of Nursing at UQ. He has worked in applied biostatistics and is experienced at QMR, Menzies School of Health, Sydney Clinical Trial Centre, so has quite wide experience. And I know that he's a starter fan.
I need to press one button, but I down. Cool. Okay, thank you for having me. What a great first talk. I've just got one slide, and this is my one slide. So I don't know if you can read it, but I'll help you read it. So I've worked as a biostatistician in academic health research for 16 years. Had 6 jobs in that time. The first 2 in England, where I'm from, and the last 4 in Sydney, Darwin, and 2 in Brisbane. So today I say, you know, what am I good at? And looking backwards, I've had a lot of experience working with randomized controlled trials. So I sell myself on that front. Someone told me the other day, Facebook and Google do loads of randomized controlled trials. It gives some people these adverts, some people not, and compare what they go on to buy. I didn't know about that. Well, I don't work with Google or any of that type of data, but all sorts of different data in the health research, biomedical sciences space. And there's so much data out there. Many things that get published are based on data that needs to be presented and interpreted and analysed correctly. So I get involved there, as well as at the design stage. So how many people do we need in order to be able to get useful informational data to answer the questions that you have in your particular setting? So that's, we might call that a sample size or power calculation. And that's something people appreciate in me now when people are writing grant applications to try and win money from government, for example, to fund their next research project. I play a big part there in collaboration with the people who know what they're talking about in that field. Right? So my background is a maths background. I studied maths at university. At the end of my 3-year degree, I thought, what now? Didn't know. Walked into the stats department at Oxford and said, do you do a master's in stats? And they said, yes, we do. But why don't you go to Southampton? They'll pay you to do a master's degree there. And it will be more applied and less theoretical. I thought, great, good idea, sounds good. Off I went to Southampton for a year and came out with a master's in stats and effectively a career in statistics. Here in Australia, the equivalent might be the Biostats Collaboration of Australia Masters of Statistics degree. That's something you do online. It's teaching from afar. You do it part-time over 3 years. And I would say that's a really good degree if you're thinking, if you want to get into a career as a biostatistician. Reason I got paid to do that master's degree, there's a worldwide shortage, okay? There's jobs. Of course, another entry point could be to do a PhD, something that people have told me to do for 16 years. So far I've refused. I hope it will be so, although it does limit how far you can go in the academic world. Okay, what else do I want to say here? So, usual situation I find myself in. I'm the data expert, or the data analyst, the stats guy, and I'm working in a field with people who know their subject area, but they're not cluey when it comes to stats. So together, we do research, we write up research, we write grant applications. So that's often the role I play. Very rarely is there another stats person involved in any of the projects I've been involved with. So in a sense, you can be a bit of a lone ranger. And that's one issue I wanted to bring up today, the issue of isolation, which is obviously not a very cool thing, right? Who do you learn from if you're the only stats person on a project? Well, ideally, you'd have a boss who's a statistician, or you'd be involved in some groups or got some good networks to support that. And that's something, I suppose, an issue that I know I have to have in the back of my head even now. But certainly in some places, Darwin was one, where I had to think carefully about that issue of isolation. I find my job very stimulating. I'm having to think hard all the time. Very often, new context, and it's a bit of an art form, stats. Okay, I could apply this method, that method, analyze it this way, that way, change this, do that. Okay, and you might do a few different ways, but you know, constantly using the brain. I've put the word freedom up there as well. So my experience of academia is there's a certain degree of freedom, right? Personally, I never work more than 40 hours in a week. I have the freedom often to read up stuff. Now, most biostatisticians say they're always too busy, got too much work. I always seem to have enough time to read what I want to read and do a bit of extra stuff. Do some cool simulations, that's what I enjoy. So far I've got away with just using one stats package called Stata. If I had time to learn another one, I'd learn R. I don't think I do have time. So yeah, the list of jobs, you can see I've worked. I got the first job, stuck on one job, stuck on one project, right? That got a little bit boring after a while. Okay. So second job, much better, lots of consulting, okay, different questions, lots of variety, I like that. And projects ended, or your involvement ended. And it wasn't this constant ongoing, oh gosh, am I doing a PhD here or what? No, things ended, turnover, I like that. Bit of time at Clinical Trials Centre, University of Sydney. And that was good to talk to some people who know a lot more than I do about stats and also clinical trials. Job number 4 was probably my key thing. I didn't actually apply for that, I just got offered it. And ended up getting a triple promotion in the space of 5 years there. And in that case, I was the first port of call and really felt like my skills got used, really enjoyed that. The picture up on the screen is from Kakadu National Park, Corpin Gorge, which is my favourite spot in the Northern Territory. Only 40 people allowed in at any one time. And feels like you've got it all to yourself. It's wonderful. Still got an ongoing relationship with Menzies in Darwin. They give me my academic title. Bit of time at QAMR, which was more a sort of consulting to hospital types role, which I didn't love, if I'm honest. And presently with UQ in a sort of collaborative research setting, which has a lot of variety because I work for 3 different centres within UQ. I've got 3 different workplaces in 1 week at the moment. But overall, happy with that and happy with the career path, although honestly I didn't think too much about it. Only really about 10 years after I started did I think probably should learn what this academic game is really about, and I did learn some stuff. So that's probably all I wanted to share with you for today.
Thank you, Mark. Our third speaker today is Susannah Leahy. Susannah started her career as an ecologist and marine biologist. During her PhD, she sought out and trained in analytical techniques that can enrich our understanding of ecological processes. She has worked in academia for natural resource management groups and for government. She now works for the Queensland Government's Department of Environment and Science, building species distribution models for the East Coast Queensland to form the basis of legislation and regional forecasts. Thank you.
Oh, that's exciting. I didn't realize that my face would be that big in that photo, so I'm just going to skip ahead to the next slide. There we go. Much more comfortable with that. All right, so I didn't realize quite what I was agreeing to, and I said, oh yeah, no, I can speak to a bunch of statistics undergrads and master's students. That sounds great, because like some of our other speakers, I haven't really had a career in statistics. It just kind of happened, and I went, oh, what happened there? Now I'm doing statistics. This is so strange. So these are lessons from a career in almost but not quite statistics. And there's cool photos because when you're doing almost but not quite statistics, you get to go to really cool places. So my career pathway is interesting because pathway kind of implies a start point and an end point destination thing and some kind of path in between. Whether it's linear or not, there's like this start and this end and you're going there. And at various times in my life, I've been really confident that I had that. And at other times in my life, I've just gone, I have no idea what I'm doing, but I'm just along for the ride. So it really never felt fully like a career pathway. And at this stage in my life, I'm perfectly okay with that. And I don't want anyone to feel guilty that they don't have a clear career pathway ahead of them. That's okay. I really struggled with the little blurb that we had to write because I didn't know how to describe myself professionally. A few years ago, I would have called myself an ecologist because I trained initially in ecology. My PhD is in ecology. But now I just call myself Ecology Plus, right? I'm plus a bunch of other things, but I'm not quite any of them. I'm plus statistics, I'm plus spatial analysis, and I'm plus remote sensing. So I go out and I'll collect data for, using satellites and planes and drone-mounted sensors. I'll go out there and I'll do spatial analysis of the landscape and different species. I'll use various kinds of statistics to support that. What really unites all the different things that I do is this kind of overarching theme of whatever we're doing in ecology or biology or what have you, I want to be doing it better. There's so many cool tools available out there that biologists and ecologists and people who aren't quite as technical just don't know about. And that goes for cool things like spatial analysis and remote sensing, but also for statistics. You'll be blown away by how little biological people know about mathematics. It's astonishing how little they know, and they will think you can do magic. It's really cool. But there's so many great ways of doing stuff that you can learn about and then take to whatever projects you're working on. And if that means that you enrich ecology or you enrich whatever other field, it doesn't matter. You're doing something better than it was done before, which is really cool. And a lot of what's happened in my career has been a series of accidents and going, ooh, that's an opportunity, I'll take that. So I was doing my undergraduate degree just before the global financial crisis. And at some point, my supervisor was doing an ecology degree, and he goes, you know, I reckon you should take a GIS course. You know, people who do GIS courses, they always have jobs. And then the global financial crisis hit, and none of my friends had jobs, but I did because I took that GIS course. And I'm very lucky that thanks to that GIS course, I have never been unemployed since. I've worked on some really shitty projects. I've had some really awful contracts, but I've always had a job thanks to that one course. So learning something technical and nitty-gritty that maybe other people don't want to do is actually really handy. And then you can bring that into other projects that you work on, just having something that you upskill in that maybe not a lot of other people know. Statistics is actually one of those things. You think, oh, you're surrounded by statisticians now. So many fields that we work in, there's actually not a lot of statisticians. You will be special and employable because of that. Now, in terms of things that were useful preparation for my current work, that's actually changed in the past 48 hours. So as of Monday morning, I'm a fisheries scientist, and I no longer work for environment and science, I work for agriculture and fisheries, which is very exciting because it's a permanent role after many years of short-term contracts. Now, what actually got me to this point was quite a few different things. One of them was actually being really upfront with people about what I don't know. Because you know, we all know that person who walks into a room and goes, oh yeah, no, you don't, I know that, don't worry. And they're so confident and they're so cocky, and we're all just waiting for them to trip and fall on their faces. And sometimes they do, and it's really satisfying, and sometimes they don't, and it's really frustrating. But don't try to be that person, because no one actually likes that person. If you don't know something, admit to it, and then people will teach you about it, or point you in the right direction, and you can teach yourself about it. And then you know it, and you don't have to ask that question again, which is great. Be willing to continue to learn. So I was very satisfied when I finished my undergraduate degree. And I walked out of my last exam and I went, I am never learning anything ever again. I am done with learning. I'm sick of this shit. And I have learned so much since then than I ever did before then. And it really blew me away. And I've actually started enjoying it. There's nothing enjoyable about being thrown in the deep end of a new project. I'm 2 days into a new job. And I've found out all these different things I'm going to have to be involved in for the next 10 years. And it's overwhelming. There's so much that I don't know. I'm going to have to learn it all. It's okay, because if we're not learning, we're getting stale. So just go, you know what? This is a learning opportunity, and that's a good thing. I'm going to make the most of it. Expressing myself effectively is really important as well. And if you guys ever have the opportunity to tutor, I highly recommend it, because that's one of the places where I learned to express myself as clearly as possible. First off, because if you can teach something, it means you definitely know it. But also because the people that you're likely to teach are going to be very different from the people you normally interact with. If you can't tutor and explain technical, difficult concepts to undergraduates or master's students or whoever you're teaching, try to explain what you're working on to your nan. Because chances are your grandmother knows nothing about statistics. But if you can explain what you're working on clearly and effectively to her, and maybe to your parents who might also not be very technical, that's actually a really good skill set, because there are very few people in your careers that you will speak to who have that technical background. You're going to be the technical people in the room. You're going to have to explain these very difficult concepts to non-technical people. Also listening. I know it doesn't seem like it right now, but I'm very capable of shutting up. And that's a really important skill to have, right? Whoever you're speaking to, it doesn't matter who they are, they will always know more than you about something. You just don't know what that thing is, right? So if they're talking about it, you don't even know. If you don't know, just shut up and listen, see what they have to say, let them finish their sentences, let them express what they're going to express to you, and you'll find out actually some really important information just because you had the patience to listen. Being courteous and respectful will get you very far. There's no reason not to be courteous and respectful to everybody you ever work with. Also understanding the why and asking questions to understand the why. So when you guys start your careers and you go into various jobs, you're going to be given a lot of information about how things work. Quite often you guys are going to be doing data entry because that's what people do with new graduates. Like, oh, I'll just give them a bunch of data entry crap. So you'll learn really well how to do something. These are our protocols. You know, you take this information and you type it here, and then we've got a double check system, and then we do this and then we do that. So you'll know how, that's fine. You've learned the process. If you understand why, you'll be able to do it better. You'll be able to pick up on mistakes. You'll care about what you're doing and have more meaningful contributions. And when you pick up and leave that job, because you will pick up and leave that job eventually, you will take with you not just the ability to enter data, which is not really that impressive, but the understanding of the processes around, okay, why do I bring in data like this? What kind of things do I have to look out for when I'm bringing it in? Okay, and if I'm going to teach somebody else to do that, I want to make sure I teach them to do this because that clearly wasn't working in that workplace. If you understand the why, you'll do a much better job of it yourself and of implementing it elsewhere. You will be a more useful person. Also, being reliable and capable. There's nothing worse than being that person in a workplace where your manager has to walk up and tap you on the shoulder and say, hey, have you done that thing? I'm still waiting for that thing. Have you done that thing? If you want to be treated like somebody who can be given a task and go off and do it, you need to act like that, right? You say, okay, I will get this project, I will do it in X amount of time, and I will get you this in that amount of time. And if you consistently perform to those standards, people will treat you that way. And that is a very nice way to be treated, because then you'll be given more and more flexibility and lenience, and you can go off and do your own thing, and that's delightful. And for me, and for all of you eventually, your name will be your reputation. When you first leave undergrad, people really don't know anything about you. So they'll kind of generalize based on your background. They'll go, oh, that person graduated from that university and that's a really good university. So that's probably a good sign. Maybe we should hire them. Or that person was a member of the Statistical Society of Australia. That's a pretty good society. Maybe we'll hire them. They'll generalize because they don't know you or anything about you. You're just a name in a big packet of names. Whereas over time, if you can demonstrate that you are a good person, that you can do work effectively, that you can listen and be respectful, that you can learn about processes and implement them better elsewhere, people will go, oh, I've heard about that lady. She's pretty good. I want to hire her above that other person because that is her reputation. And I highly recommend that because that's how I got headhunted. In terms of what an employer is looking for in your skill set, the ability to take photos with a level horizon isn't always very important. Technical skills. So if I'm hiring a statistician for my team, I really want them to know how to process data, how to look at data, look for outliers, find out what analysis is suitable for answering that particular research question, know the limitations of that analysis, know all of that technical nitty-gritty. I want to be confident that they know that stuff. And capable in this day and age of probably scripting it so that once that person has left the team, I still have access to those scripts and I can still run those analyses. So just having those core skills that you can say, hey, I can do X, Y, and Z, and I can do it in R, Python, and what have you. I want that work ethic as well. So the one where I can trust you with a project and say, hey, I'd like this data analyzed. How long do you think it'll take? Okay, I'll give you that amount of time and I'll come back and check on you. I don't want to find out that I come back and you're on Facebook and nothing's been done. I don't want to hire that person and I will make sure that they're not part of my team anymore. So be the person that contributes to the team that has that good work ethic. And interact, right? Because as statisticians, you're going to be statistical experts in your fields, and you will almost never be in an environment where you get to hang around with a bunch of statisticians. As Mark was saying, you can actually be extremely isolating, and you have to know how to interact. And that might mean, sitting down and nutting out with a health scientist who has no understanding of statistics, exactly what they're trying to figure out with their malaria treatment in terms of whether or not that's effective. You'll be in situations like that where you just need to reach out to people who are specialists in totally different fields that you know nothing about, but you're going to work together to do something better together. Because individually, you're all just specialists floating in your own little bubbles. And what I highly recommend is developing a solid personal process for projects. So essentially a workflow. So that way you're not surprised, and I initially was very messy with this and was always surprised when somebody would give me data and say, go off and do something with it. So I want to learn more about the data, about how it was collected, about what kind of uncertainty is in there, what kind of errors I'm likely to find. I have a personal process for bringing it in and checking for other errors. and for doing some basic exploratory stuff and bringing it to my manager and saying, okay, these are the rough patterns. Let's talk more about what you're interested in terms of, are you looking for cause and effect here? Are you looking for different things happening between these variables? Having that process, because otherwise every new project is a surprise, and it really shouldn't be, because it's all just data about something and somebody wants an answer. That's the sequence of boxes and arrows, really. And you just need to have a sequence of boxes and arrows that works for you and be really consistent with that. In terms of what to expect when you guys enter a statistical workplace environment, people will definitely think you can do magic, and that can go to your head. Because you'll get overly confident in your abilities and you will make a really stupid mistake. I have made a spectacularly stupid mistake that there's not time to go into now, but you can ask me about later over drinks. As I mentioned earlier, always learning, and I kind of put that between the sad face and the smiley face because it can be very exhausting, but it's also very stimulating. And at this stage in my life, I appreciate it, but 10 years ago, I hated it. It goes back and forth. And as Mark mentioned earlier, it's stimulating work, it's interesting work, right? So you're solving problems. You're being given puzzles every day. How cool is that, right? How many people get to say, oh, I've got a Rubik's Cube to solve every day, and each one's more complicated than the last. And sometimes, not always, the work can be really meaningful, right? So actually working with that health project on how to better distribute resources for vaccination programs of polio across Sri Lanka. Like, that's a really cool project to be involved in, and you can optimize that, and you can have a legitimate health outcome. Even though you know nothing about polio, you can help with that project. How cool is that, right? So if you're looking for meaningful work, this is actually a really cool place to be. And obviously, there's really good career prospects. So there are definitely worse fields to be in right now. In hindsight, things that I would have done differently is, I still struggle with this one, is developing realistic estimates of how long things will take, including giving a 15-minute presentation. Sorry. So when somebody gives you some data, sends you data at 3 o'clock on a Tuesday afternoon, and says, oh, can you just look at this so we can talk about it tomorrow? I want to know X, Y, and Z. And you go, oh yeah, I'll just crack into it now. And suddenly it's 8 o'clock at night, and you're like, my God, this is so messy. And then suddenly they go, oh, and I just want a brief little report. It'll just take you a few minutes, and then 2 weeks happen. Right? So developing a realistic estimate of what this data is going to look like, what they want from it, how long it's going to take me, and then add 50%. The value of changing fields. So I started out as an ecologist, and I felt like a total loser when I went into statistics. Not because you guys are losers, but because I felt like a failure as an ecologist. Like, well, clearly other people are making awesome careers in ecology, and I'm not. What's wrong with me? Like, actually, going into statistics, if I could pronounce it, was one of the best things I did for my career. Going into GIS was one of the best things I could do, and remote sensing. And I found that really interesting. And I think, while I'm not an ecologist anymore, whatever I am is way more interesting than having just been an ecologist, and I'm okay with that. And not comparing your career path thing to others. Because, you know, some people might go into academia and they'll do a Swiss postdoc and they'll be working in Norway and they'll be going to international conferences and they'll be posting photos of that on Facebook. And other people will just vanish entirely and go have children and they'll get lots of photos of that on Facebook. And other people will work 80 hours a week and be very rich. And other people will work 40 hours a week and have a couple of kids and do sports on the weekend. And you can fit in any of those things and it really doesn't matter. But definitely comparing yourself to other people who are doing those things is a recipe for making you feel like crap. So thank you very much for your time. And we're going to go on to Dan now, I think.
Dan is from CSIRO, where he's a senior research scientist. He uses his knowledge of statistics and environmental phenomena, so it can't say that word, to tackle challenging problems in diverse scientific domains, including hydrology, population biology, and agriculture. Dan's main research interests are computational statistics and quantification of uncertainty predictions made using complex physical models and environmental processes. He's also a keen interest in the stock market and how statistics and machine learning approaches will be profitable for automated trading. Thank you. Make us rich.
It's free to assist me. Prove another point as well. So thanks for having me. Yes, that is me. Yes, that's the name of the presentation. So I thought I'd start with basically what happens to me every time I go to a party, which is, you know, someone will say to you, what do you do? And if you say, I'm a statistician, and they've been to university, with high probability, they will say, oh yes, I did statistics in first year and I hated it. And, you know, I trolled Google Images for a horrific box plot, and you know, I think this kind of sums up most people's, you know, feelings of statistics. It's things like box plots. They're boring. In this case, they're also brown. They're on something about prairie dog hill diameters by site, which people might think is not particularly interesting either. And to make matters worse, if you look at the bottom, it's also simulated prairie dog hill diameters by site. So I think it takes a particular type of person to fall in love with statistics. And I think we've already seen from most of the speakers, and I've heard a few other people saying how they got to statistics as well. Most people, I think, come to statistics through another doorway. So, and they kind of, they fall in love with it, I guess, once they realize how powerful it is, and that the person with statistical knowledge becomes extremely useful to an employer. So it makes getting a job really easy, and you actually, a lot of the time you just pick and choose and things just fall in your lap. It makes life very easy if you're lazy like me, and have a beard and don't shave and all the rest. So yeah, my undergrad studies were actually environmental science in ecology and marine science and that sort of stuff. And after I finished my undergrad degree, so I got a job as a water quality modeler, and I was like, I don't know what that is, but I'm going to apply for that job because I need a job. And I got it, which was cool. And there's a little asterisk there. Anything with an asterisk I'll come back to later because there's a lesson there. And then I went on to do an MSc and a PhD in maths statistics. Some of the MSc stuff actually was through the, what's it called, BCA. Yeah, I did a couple of their courses and they were really good, those online, you know, remote learning kind of things. But yeah, I guess if I had to sort of think about what led me into statistics, and I remember being in a second year ecology class, and one of the professors who was a avian biologist said, do as many statistics subjects as you can as your elective subjects. And I was like, oh, that's interesting. Like, we did first year stats and it was pretty boring, but, and she said, they're not only useful, but they will set you apart from others. I was like, ah, right. So, and this probably ties into the other talk where you were saying you felt like a failure because you're an ecologist and you ended up working as a quantitative ecologist. But yeah, if you can be in that intersection, the Venn diagram, you're all of a sudden, you're so different from everyone else. And we'll have more Venn diagrams throughout the talk because they're just good for illustrating points. So yeah, be the guy in the Venn diagram in the intersection. And that got me my first job, really, because I didn't have any background in water quality modeling. I did an environmental science degree, so I knew about environmental stuff. I'd done some stats and maths as electives in undergrad, and that got me over the line. You know, they were kind of looking for someone that probably didn't even exist in terms of the selection criteria for that job. So another asterisk, I'll come back to that. My job, I got this job with the Queensland government, and they have programs where they'll even pay for some of your studies, which is great. I'm 38 and I've just finished paying off my HEX debt, so get as much free study as you can get. So then I did my MSc, and part of that, we had to do a research project. So I did a research project with Phil Pollett, who's a professor in the maths department at UQ. And that was really good and went really well. And then Phil said, do you want to do a PhD? We could sort of keep going with what you've been doing in your MSc. And he said, we've got these top-up scholarships through Mascos, which is a bit like ASEMS now, it's one of these Centre of Excellence things. And when I looked at sort of how much it was tax-free, I was like, actually, I can quit my job. And I had a mortgage at the time, right? So I could actually quit my job and still pay my mortgage and do a PhD. So that's cool, I'll do that. So I did that. And Yeah, and so I was kind of thinking, well, I'm doing a PhD in stats, and I've done this MSc in maths. I'm kind of moving away from environmental stuff now. That was all in the past. You know, water quality and hydrology, that was just this tool, the stepping stone, you know, on the way to becoming a statistician. So anyway, I did my 3-year PhD, and towards the end of my PhD, this job came up at CSIRO, and for a postdoc, and it was in Long Pocket, which is like a 5-minute walk from UQ as well. And yeah, they wanted a PhD graduate who had experience with hydrology and water quality. And we're like, this is me, I'm the guy in the Venn diagram. So that was great. So I've been at CSIRO now for 8.5 years, and it's been great. My postdoc position turned into a permanent job. So getting a stable permanent job in science, in research, is challenging. So I'm really lucky in that respect. And yeah, I work on applied statistical problems in a range of areas, in environmental domains and agricultural domains mostly. So being a statistician, applied statistician, is really great if you enjoy learning about other areas of science, because you're always collaborating with new people and learning new things. I never call myself a statistician, I call myself a scientist, because I think the world's too interesting and science is too big and interesting to sort of pigeonhole yourself like that. And yeah, and I think I really think it was a good thing that I took a job in industry before I did a PhD. It gave me a lot of perspective about what skills are in demand and what jobs exist outside of academia, I guess. So within CSIRO, I just thought I'd throw up some of the random projects that I've been working on over the last 8.5 years. The last couple of years I've been working on this project, which was in the news and stuff, which was cool, which was the Debug Innisfail project. So this was a biocontrol project in Innisfail, where they had this van and it drove around spraying out sterilized male mosquitoes. I think they released like over 1 million mosquitoes over several months. And the idea there was to try and crash the mosquito populations up in Innisfail, which worked. So that was pretty cool to be involved with. And that was a collaboration with the company Verily, which used to be Google Life Sciences, their biological arm, I suppose. Before that, I was working on bioregional assessments, we were doing uncertainty quantification, I guess, from models to predict the impacts of coal seam gas development. So another big important issue for the country. Before that, was working on soil carbon modelling. So we're using Bayesian hierarchical models to look at uncertainty in soil carbon stocks across Australia. That's important now because Australia has to basically do carbon accounting on soil, so on dirt, how much carbon is there stored in the dirt, and make sure it doesn't go up into the atmosphere. Before that, or sort of parallel to that, we were also doing work trying to calculate or doing uncertainty quantification. So what are the error bars on the modelled tons of dirt that people predict is going into the Great Barrier Reef Lagoon from different catchments? So these are all really challenging, nasty, difficult problems, but they're really interesting as well. So I guess I did my PhD in statistics methodology development, and I mostly used simulated data during that time. And I now do applied research and almost always use real data with real questions to answer. And I think both of these are challenging and useful, but I think, yeah, applied stats offers the greater challenges. And if you're successful, you're more likely to see real impact. And I also think it's more exciting to solve real problems that people care about, rather than just sort of making up or just picking mathematical problems like what's the probability mass function of a square of a Poisson random variable. It's like you could publish a paper on it, but I don't know, is it going to change the world? Probably not. Yeah, and also, I guess this is the thing as well, like when you get real data, you know, the model is always wrong, right? So you've got to try and find a model that is sort of right. And along the way, you're going to try a lot of different things. So in applied stats, you tend to learn a lot very fast because of that. So my thoughts on a research career. most people don't find their PhD easy. Occasionally you find someone who's like, yeah, my PhD was a breeze. I didn't think mine was. I finished in 3 years, which was good, but it wasn't easy. So expect it, if you decide to do one, expect it to be challenging, but also rewarding. Do it for a good reason, not just because it seems like an easy step after you finish honours. And don't feel like you have to be in a university to be a research scientist either. There's lots of opportunities in government and industry these days. What do we look for in new recruits? Basically solid understanding of stats in some form, and that's pretty broad. Strong computational skills, so usually R or Python is a scripting language, and then hopefully something else, maybe some C++ or something if you need to speed something up. And again, there's an asterisk here. Good written and verbal communication skills are essential, and the first step to demonstrating that is your job application. The number of job applications I've seen that haven't even been spell checked always boggles my mind. Okay, the most important one is this last one. Demonstrated evidence of skills and experience. Demonstrated being key. Subjects don't count here. So make yourself stand out from other people. It might mean, you know, make an R package, even if it's crap, make an R package in your spare time just to demonstrate that you can do that. You know, enter some Kaggle competitions so that your code is up there and people can benchmark it against other people. You can do vacation internships, analyze some data for fun, as long as it's not prairie dogs and you don't make brown box plots. Or even, and this is the whole finance thing, this is something I did with a mate, is we made a startup to try and do some algorithmic trading, which was really fun, and it kept us really busy for a few years. And I learned all sorts of machine learning doing that, and using Amazon Web Services to, you know, launch clusters in the cloud, all sorts of stuff. What should you expect? Don't expect to get paid heaps of money. Don't expect to climb to the top of an organization without getting a lot of experience first. And I wouldn't say focus too much on salary to start with either. Focus on upskilling. I think somebody else said that as well. If you do a PhD, expect to be challenged, expect to live modestly. If you go into academia, expect to experience that it might be difficult to settle down, which is great if you want to travel and see the world. My wife currently works in the UK and has done for the length of time that I've been growing this beard, so there you go. Yeah, expect to have an interesting and challenging job though, and you'll continually learn new things. So if your whole life isn't about money and it's about, you know, having a job that you like going to, that you can dress like me every day and not wear a suit and those sorts of things, then that might be good. Yeah, and I like this point before as well. Don't be afraid to admit that you are still learning, and to use that as an opportunity to get advice from people who are more experienced, and I still do this, and I think that's really important. Okay, so the asterisk points. There's lessons here. I got a job as a water quality modeler. What was the lesson? Try not to focus on landing the perfect job. Just try to focus on getting a good job and get some experience under your belt, and just use it as an opportunity to soak up as much as you can, learn as much as you can, so that you can get that demonstrated experience, because that's what counts when you're looking for a job. I got my employer to pay for some of my studies, so make the most of every opportunity offered by your employer. I also got to spend 6 months working remotely in the UK because my wife was over there, so you've got to look into these things. What can you squeeze out of your employer? As I said, so I don't know, probably a lot of people in the room know some R or Python. How many people know some C++? A little bit, yeah, a little bit, not very many people, few people. This book, it's still on my bookshelf. I bought one of these always look so naff. I see them in like, they used to be in like Book World and stuff. Teach yourself C++ in 24 hours. And I was like, oh, that's it. So I bought one, and I did. They totally work, and it's really good because they're broken up into these 1-hour lessons, and it's just like doing a university course. I've never done C++ at uni, and I do it all the time in my job now, thanks to that book. And if anyone would like it, I'd be happy to gift it to somebody if they can use it, because it doesn't get used anymore. Some other advice, I would say look at jobs, and not just jobs locally. Get onto like the web and go you know, data science jobs in London or something. You'll find jobs by Google or, you know, banks, whatever you're interested in, and you'll see what they're looking for, exactly what they're looking for, right? Yeah, and one point, so I was going to make, during my PhD, I did everything in MATLAB, and when I left like uni and got a job with CSIRO, I was like, why did I do all this MATLAB stuff? Nobody uses it. You have to pay for it. It's not, you know, it's just dumb. So nobody asks for MATLAB skills. So yeah, I'd say don't be scared to, you know, some people in stats really hate data science and machine learning and stuff. Yeah. But don't be afraid to call yourself a data scientist that'll help you get a job. And don't be afraid to apply for jobs like water quality modeler if you don't have all of the, you know, the skills and the selection criteria either, because most of the time they're looking for a unicorn. Data science is like what, the intersection of domain expertise, so maybe banking, mathematics, and computer science. So who has all of those things? Like nobody. And if they do, they're probably working at Google or something. Okay, and some further advice I would say is one of the most important assets you can have, other than your name being a brand, because I really like that, is your network. And Silicon Valley tries to tell us that your network is all about social media and crap like LinkedIn. And I don't use it, like I kind of use it, but it's just like, I'm like, I think I'm connected to like 500 people that I don't even know, do you know what I mean? So you just end up with this massive feed. The best thing you can do is just to talk to people at events like this or at a conference or something like that. So they know who you are, they know your name, and then when you know, a job comes up for a research assistant, and they go, hey, there was that guy at that conference. He seemed pretty switched on. Maybe I'll like see if he wants, because you're, you know, you're a known quantity. Then they kind of have a feel for you, rather than I've got a CV from someone who I've never met and I don't know what they're like and all the rest. So that's about as much wisdom or lack thereof that I can impart. So I'll leave it there.
Our last speaker today is Dominic Gorse from QFAB. So a lot of people probably know QFAB around universities. He has 20 years of experience in software development, information management, data mining, data modeling applied to life science. He's currently the director of a consulting branch of QCIF, a non-profit public company providing customized data analytics to life science and clinical researchers. Dominic spent 6 years with BioLayer, where he led the development of its technology products. He was instrumental in helping the company raise $7 million in research grants, $8 million in capital venture, and a list on the Australian Stock Exchange.
Thank you.
Well, good evening, everyone. So QCIF stands for the Queensland Cyber Infrastructure Foundation, and I'm the director of QFAB Athletics, which is a unit within QCIF, and it's like a data science consulting unit. So I've got a very different career pathway, and what I've done here is to list jobs that I've held, and then what technical skills and business skills I've learned doing those jobs. And then I've got some screenshot of software or tools that I have developed. So I will start my career with a PhD, and it was in computational chemistry. And I was studying how molecules interact when they are in their excited state. So to do this, I had to do a lot of high performance computing to do quantum chemistry, but also I had to write a software, which is the one there, to be able to visualize the molecules in 3D. So it was at the early stage of 3D and computers, and I did that in C++. So I have to learn software development there. But also behind the software, there was a lot of calculus in terms of being able to calculate the energies, but also to do optimization like simulated annealing and all of those. Then I did a postdoc, which was very eventless, maybe doing the same thing, but knowing a bit more about drug discovery. And then I had to make a choice. Should I join industry or should I continue in academia? And so I applied for both type of position and didn't get anything in academia, so I took a job in industry. And I became a software developer in a software company. Now, if you can see the screenshot, I was there to develop, again, 3D models in C++. And that's why I was hired. So what I did there is to learn about real software development in industry, in a company that does this in a professional way. And I had to interact with clients. And then I had the chance to join the startup in drug discovery. And I think this is really when my career started. And I've learned a lot of things there. So that's where I started to learn about statistics. I did a lot of data management, data mining, machine learning, and what at the time was called, could be called big data. But I also learned a lot of skills in business, like leading a team, managing people, managing projects, and managing intellectual property. And then I joined another startup in Brisbane. Technical skills were the same ones as before, but I also did a lot of experimental design because I was leading the R&D activities. And then that's really on the business side that I learned a lot, dealing with venture capital, doing an IPO, doing all the commercialization and all of that. And then I became a technical manager at QFab, and I've been there for 11 years, and I'm now the director. Still using the same technical skills, but adding new ones like cloud computing, and because we are doing a lot of health data, I'm doing also data governance. And on the business side, knowing how to run a consulting unit, all the financial, all the legal, the contract, and all of that. So what I've done here is to show the proportion of technical work versus business work during my career. So at the start, it was all technical, and then I did project management, team leadership, and now it's 80% business, running a business, and maybe 20% technical. Now, this here is what I would call my seniority. So it's some kind of an estimation of how much responsibility I was having in the organization, and how many people are reporting to me, and how many people I'm reporting to. So I will start with a PhD. So this is a baseline, was my responsibility during the PhD. And the top here is being a CEO reporting to a board. So doing the postdoc, there was a bit of an increase. This was my first job in industry. I was not recognized as a PhD, but I took the job because I saw that I could learn a lot from that company and there was a good fit in terms of my skills. And that gave me the possibility to get a job in my domain in drug discovery, and I recognized my PhD then. But the growth within the company was quite fast. In the startup, they're growing very quickly, so you have always opportunity to take new responsibilities. And then I was headhunted by a second biotech startup company, which is again a very good thing because when you are headhunted, you can negotiate a bit more what responsibility you will get. And again, there was within this startup company a lot of opportunity for growth until there is a crisis, because in startup company, there is growth and then there is sometimes failure. So it was a time where I was quite unsure whether the company would fail or would continue. And I decided to change job, and I joined QFab as a technical manager. So that went down. And within QFab, the growth is very slow because it's an organization it's not growing as fast as a startup. So I felt I need to do an MBA to be able to go to the next step. And that was very useful in becoming a CEO in 2015. But my main outcome as a CEO was to negotiate a merger with QCIF. And because QCIF was bigger than us, in fact, what happened that QFAB became part of QCIF. So I am now reporting to the CEO of QCIF. So I went down. What I wanted to show there is, in my career, there were times where I could jump in responsibilities. This is not salary, by the way, it's just responsibilities. You can jump, but sometimes you need to take a step backward. And if you see the opportunity to grow within that organization, I think it's a good thing to do. So now I will tell you a bit more about QFAB. I would call it as being a data science consulting unit for researchers. We are a non-for-profit public company, but we are owned by the 7 universities in Queensland. So this is quite a weird structure because I am employed by UQ. I am seconded to QCIF. So we have to be like a consulting unit living within the ecosystem of universities, and not just one, 7 of them. What we do is to provide all the cloud computing, storage, software platform, tools, but also the skills in bioinformatics and biostatistics to enable researchers to get the most out of their research data. So this is the team, we are 9, and we cover the full spectrum from the cloud sysadmin to the domain knowledge. Yeah, first. In yellow, this is our biostatistician. So Anne is leading the team, and we have Justin and Nico. And what do they do? So they coach HDR students and ECRs in helping them to analyze their data. They deliver training workshops, mainly workshop on how to do statistics with R. They provide what we call consultations, which are meetings with researchers. So it could be a clinician, it can be a nurse, it can be a lab science researcher. And they will help them during that consultation in terms of guiding them in what analysis to do, how to do the data processing, the cleaning, and all of that. They also participate in projects where they will analyze health and omics, so genomics, proteomics, metabolomics data. And they also develop methods in collaboration with researchers. So for example, analyzing all those omics layers at the same time, doing an integrative analysis is something that is quite tricky at this stage. And they also participate in the business aspect by developing and writing proposals. They will try to estimate the requirements, find solution, and estimate time that it will take to do that job. As a consulting unit in university, we only charge for salary recovery. So if we get it wrong, then that means that we are in trouble. And what do they like? Diversity of task, of the data type, of the project, of the client. They always meet different people every day. They like the supportive and collaborative environments, and they really enjoy contributing to some exciting research projects. So what are we looking for when we are hiring? The first one is really, of course, strong analytical skills, ability, and expertise in statistics. So when they do consultations and they are in front of a clinician who is the director of a unit in an hospital, they will expect us to have expertise in statistics. They will also need to have domain knowledge. And for us, it is mainly biology and health, but we are about to do also ecology. And then there is a fit with the organization, culture, and values. Now, this is a tricky one because that's not something that you will see on the website most of the time, but this is very important for us. And when we ask these questions like, what did you do when you had a conflict with your colleague and all of those, it is really to find what are your values and if you will fit in the team. And we had many cases, or several, where a person will have had the technical skills, the domain knowledge, but not the fit. And that's very important for us. We will be looking for the ability to learn, the willingness to continue to learn all the time. Having good people skills, because we need to interact with clients, but also good people skills with the team. We are a small team, and we want to keep it very friendly. And we are looking for people able to work independently in a team, which for me means to be proactive, to be able to work under minimum supervision, and to be a good team player. So if you fit all of that, let me know, because we are about to recruit a biostatistician. Now this is the last slide, lesson learned. I found that working with startup was very stimulating, and it's a very good way to fast track the career. There is a lot of risk in doing that. At the same time, it's like a financial market. But that's something I would do again if I had to do that. I would advise to participate in GoVac, LSAC, there is one this weekend, and all those events where you can be part of a team and participate and solve a problem, a real problem. If you are a winner of that competition with the team that you are in, you get a lot of visibility, but that's also something very good to put on the CV. A volunteer for internship. This is a good way to demonstrate your skills in a real case, but also to get a reference. So I've seen a couple of interns that came to QFAB, and having done an internship was useful for them to get a job in industry. And the last one is when you apply for a job, really, you need to make it as easy as possible for us. And please address the selection criteria. It's not to be we don't want to be a pain, but we want the process to be fair, and we want to assess everyone against those criteria. So if you've done the work for us, it's quite easy. If you don't do it, then it will just go down the pile. So if you want to work in academia, in government, and even if you find any selection criteria in the ad, you should really address them. And that's all I wanted to say. Thank you.
Q&A session. So the idea is got these potential employers. Feel free to ask questions. Anything that you would want to know from these people? So what is, it's a big step to do an ecology degree. Actually, I did Susannah. How do you go from doing an ecology degree to jumping into that first step of becoming a statistician?
Having some of the skills necessary to do that. So you have electives in your undergraduate degrees. Don't use them to take underwater basket weaving. Use them to take something useful. So, you know, when people suggest that you take as many different statistics courses as possible or GIS courses, take something that interests you. I mean, don't make yourself miserable, but something that is definitely different to what your peers are taking, that is different from your field. And then when you see jobs advertised, you're more willing to have a go at something that needs a bit of analysis because, oh, I've got those skills. So you're more willing to take a job that, in my case, used a bit more spatial analysis because, oh, I actually learned that kind of stuff, so I can have a go at that. Or for myself as well, when I did my master's degree, instead of just doing a normal ecological master's degree, I could demonstrate those weird side skills that I had in my thesis. Oh, I'm going to do some spatial analysis because I can, because the project will be more interesting because of it, and then I've got those demonstrated skill sets that I take.
Same question.
Which one, sorry?
So did you go straight into stats, or did you're a chemist?
Yes, I was a computational chemist. And I really had to learn to start when I joined the first startup, where I was given a lot of data to analyze. And the company was a big IP for big pharma to transform this amount of data into something that we can sell to big pharma. So I had to learn statistics by doing it. I was quite lucky that we were in a team with over six in that team, and 4 had a statistical background, so we were learning from each other.
So do people think that doing a degree in another area and then jumping into a stats is a barrier, or is it helpful?
I don't say it's a barrier.
I suspect there's more actual statistical graduates now than at any other time in history, right? Because when all of us were getting into statistics, it was more of an accident. We were doing other things and we needed statistics. Whereas I get the impression most of you guys in this room are doing a statistics degree. You've already figured out that there's jobs here to be done, you're going to do them. So right off the bat, you're more equipped than what we were going into it. That's a pretty good head start.
So put your hand up.
So spend your elective doing something you enjoy. Like I did helps to Madonna, and I also did a lot of evolution. So if you've already got a major business background, you might as well do things that probably wise.
Yes.
Sorry. This is probably directed at Mark, but for everybody as well. At the moment, I'm dodging a PhD. I'm doing a master's in biostatistics through BCA, and I'm avoiding doing a PhD. I keep on having it recommended to me to do one. Do you feel it would be a good step after finishing the master's to go on to do that, or do you think that's actually avoiding it? I should explain, so my background, I'm a vet, but doing the master's.
Okay, so increasingly there's an expectation or a pressure that people do a PhD that can't get an I these days without a PhD. That's what some people will say. So I see myself as research support. However, if I was going to try and make it as an out-and-out researcher, like owning an area of research, writing papers in that field, in a very tough academic environment that it is today, super competitive, hard to get funding, etc., then you need to own an area. So I'm not quite sure whether you want to do more research support consulting like I do and what Donald's people do, or whether you want to be a research lead. If it's research leads, PhD in that area you want to lead. Yeah, so you know the literature in that field. I mean, a really powerful thing I can tell you today is if you have stats and the domain knowledge, I just have the stats, by the way, but if you have stats and the domain, super powerful, you could be director of places, like both those two things.
So, I was going to say something really contentious, which is, and I was talking with other academic colleagues recently about this. You can almost view doing a PhD, I'm going to get a hand in the air, so you can almost view the PhD machine as a bit of a pyramid scheme as well. In academia, people are trying to build their research career, right? They're trying to be the lead, and the way that you do that is to recruit people because it's very little. It's essentially slave labor. Like if I look at how many hours I've put into my PhD and like how many papers and how many hours I work, it's pretty bad. Like you earn more money working with words. So you don't do it for the money, you do it because you can see the long-term benefit to your career. But yeah, I think you have to keep in mind as well that if somebody's suggesting to you, oh, you should do a PhD, just question their motives as well. Like if they're suggesting you do it with them, then there's a reason for that, and it's probably because take it as a compliment. It's because they obviously think you're really good, right? And they're like, I can get so many papers. Yeah, I think you definitely want to do a PhD. If you're going to invest the pain and suffering that goes into doing a PhD, do it in something that you think is going to set you on that trajectory to get to where you want to go, and not just somebody said you should.
I work in, well, now for a not-for-profit, so but a lot of the jobs I've applied for have said you need a master's or you need a PhD. I noticed on one of the slides that said minimum requirements, and that is literally what I've found. Like, I don't have either. Neither. But it's just a way to clear. You've got too many applicants. It's a way to clear the slate. These you've actually got specialist knowledge. If you can demonstrate that otherwise, so I can show my work history. I've written articles, and I can show these other things. Having PhD is just a simple way. Like you need to have all these job requirements because there's too many applicants, and they're just trying to weed people out with it. PhD is just one of those really quick ways to weed someone out. You know this person has got commitment to something, they know their area well. It's just a simple tip. Quick exercise because of that. If you can show it other way, you might really calculate it. We just hold them up. That's the main thing. When you do apply for a job, call up within 2 days and go, my name's Nigel. It's an application. Just want to make sure you've got it. Is there any other questions you have? And that's what the two jobs. Because most people don't actually follow up.
So this one's probably mostly for Nigel, but if anyone else feel free to jump in. So I'm a data analyst in a very non-data company. So Nigel, your anecdote about giving you all the data from North Queensland, that really spoke to me. But so I'm kind of in mostly the reporting space, so very Excel heavy, very much operational metrics, that kind of thing. What would you say to someone who like me, who is in that space but really wants to move into the more scientific, analytical, machine learning kind of space? Doing more predictive stuff. That kind of.
Mostly, I've got there, and I'm training my organisation there now, is by genius, and it is by mapping their processes, seeing that you can literally get dashboards out. Just putting that, getting some BI behind it for their reporting processes. To start, because then it frees their time and frees your time. And then you've got more free time. You can start doing things like that, machine learning, thing about trying to find members. Yeah, that was something I took for myself. Actually, copied some of this, borrowed some years ago. And then once I got some results, I went, here's something you can do. Here's the 100 people you should be calling. And it was just that way, like just freeing up their time and your time. Because it is virtual. Doing this work, especially reporting, I could ask the same 4 questions. Put your dashboard that I created. Log in again, I'll show you that process. It is, they take a while to do that. They just don't. It's just, this is the process. Then Nigel and I will build that. It's like, no, I've got a dashboard for you now. Yeah. And that's the way. Just freeing their time.
Letting people know what's possible.
Just sometimes
The few speakers actually mentioned about isolation. I wonder how you guys actually dealt with isolation in your job.
So by actually going out and joining groups a little bit like this or more informal ones. So when I started in Queensland government, I was fortunate that I randomly bumped into in the hallway people who were like, oh, I do stats type stuff. Maybe we should sit around and have coffee together. Yeah, that sounds really dorky. Actually, it was really fun because suddenly you feel a little bit less isolated. And if you have a weird off-the-wall problem that there's no one in your team to talk about, actually, here's a person that you can grab a coffee with and have a chat, and they might have a good idea or point you towards a paper or a process you haven't considered.
There's a logo up on my last slide that said burger. I spelled it badly. That's the Brisbane Users of R group. They meet up once a month. Any level of art can come along. We've worked on a few projects. We've got some really interesting data. We play around with it. We just catch up. It's over at Bank once a month. We drink beer. 2 hours, and occasionally it's interesting discussions. Having this university. That would be good.
Did you have a question? No, you. Yeah, no, it was. Yes.
Thanks for sharing your career path. They are really encouraging. And then choose statistics, making feel, oh, that's the right choice. So basically my question is for everyone, because I can see most of you guys have very strong academic background, either a PhD or many experience in research. So my question is really, what's the reason make you to jump off the academia? Is that because of the contract finish, or just to think of create a problem and then you solve it by yourself, or just some other reason? And then also, is there any missing you are missing in academia? Is there anything you still missing?
So having a career in academia is very difficult and very challenging. We had some alumni who decided to be a researcher and that became a researcher. But this is really something that you need to think and to do from the start, because you need to create a track record of publication and demonstrating that you can be a researcher to get grant. And this is a cycle which is very difficult. If you're not a good leader in academia and you are more research support, you are on short contract most of the time, and really quite challenging. So the reasons why many people who leave academia that I've seen is because they are fed up with the cycle of grants, and they want more stability, and they decide to do something else.
The reason there's no proper academics in this panel is because they're all sitting at home writing grants so that they have a job in a month's time.
And saying that, I'm going to say that we need to, as so I am at the university, and I guess I'm probably out academic in the fact that I don't have a PhD, and I'm currently enrolled in a PhD for the same reason. No, but the point is, how many people are PhD students here? So quite a few. It shouldn't be your path necessarily to go, I'm doing a PhD and I'm going into academia. That will be, I think they were saying, 1 in 5 people are employed in academia. We need to get out of the habit of saying, if I didn't make academia, I failed. No, you could be making $1 million in a financial company. It's not valid. I wish I was making that, although I'm saying that. You have to have also expectations. I'm pretty sure if I went to the financial company, maybe I'd earn $20,000 or $30,000 more than I do now. It's probably not going to be $1 million. So expectations of what you're getting is really important.
My name is Chen. Last year PhD student at UIMR. My question is about do you have any good programming practice you have applied in your scripting? Do you think it can dramatically improve productivity of people here or whoever who writes code?
May I have my codes?
I'd probably say me. I've never had any, I'd say, formal training in programming other than that book that I showed you. But I think actually doing some reading around, reading a book on C++ or even some software engineering practices gives you some of the understanding of what makes good design practices. So, using functions, making code reusable so that the bug, where it's occurring, I suppose, rather than having sort of spaghetti code. And I think one of the things I've recently started using in the last couple of years, which has really helped a lot, is using things like GitHub as well. So, and that's nice because that's been tied in nicely with a lot of Hadley's tools as well. So you can now do install package from your GitHub account, share our packages. So,
The art conference that was here in Brisbane, first one was in the USA Europe, a few months ago. The last plenary, we all had to write nice things, but websites.
another thing I'd say, people always find my code looks a bit weird, I guess. I use really long variable names, but I never have to comment on code. That's another thing. So I'm really verbose with variable names to the point where you read a line of code and you know what it's doing. Always yeah. So comments are good place. But yeah, but writing easy to read code and not variables that are called A and B and X. That helps.
My team goes with the what if you get just hit by a bus philosophy, which is that all of your stuff, especially as a PhD student, should be useful to someone else. If you step out of this building tonight and get hit by a bus, please don't step out of the building.
What if you win lots?
What if you win lots?
Yes.
Somebody came out and help, right? So, making sure your materials have some.
So my question is to the next speaker. You say that don't compare your head to others, but I myself sometimes found that it is useful to compare because it can encourage myself to do more.
Yes. Also no. Certainly, you know, saying, oh, you know, somebody else is publishing from their PhD. Oh, I should probably try doing that. I'm publishing from my PhD. Oh, that person got 6 publications under their PhD and I got 3.
Yeah.
It's just, it's a slippery slope between that motivation and going too far and just feeling terrible about yourself. Because their project is completely different, their life is completely different. They can do that with the project that they have and I can't. And so it's really a gray area, I find, of going, oh, well, that person's comparable to me, I should be performing at their level. And if that works as a motivator for you, sure. But if you find yourself, you know, curled up in the corner crying, it's probably a good place to stop and go, I'm on my own path now.
Any more questions?
Yeah, I have a question for them because I say you have changed your many projects from different areas. I want to ask, do you use some transferable skills or you just learn all different new skills?
I suppose the thing that's common between them. So yeah, that's a good question. And yeah, I guess the commonality is the stats, right? So every project you might actually learn new stats, but you kind of got this base set of tools that you use. And then within CSIRO, I'm in Data 61, which is kind of like the data science business unit. But then we work with other business units on their projects. And so, yeah, I guess the stats stuff tends to be reusable. But then you start to find, particularly, suppose you end up sort of working in a domain, and for me it's environment, agriculture, and so there's a lot of overlap between the sorts of problems you're working on. It's probably the same in health, like you start to get some understanding of, the biology of human and immunology, and we're all I'm making it up. So I think you learn things, but you start to learn the right questions to ask as well. I guess part of it is how to interrogate, people that you're working with to get that information out of them as well. And acting dumb really helps. Like, not acting dumb, but I don't know if people watch like Louis Theroux documentaries, but I really like the way he interviews people. He's sort of very childlike, so I ask a lot of questions and assuming that you know nothing, even if you maybe do know a bit, assuming you kind of know nothing, hear what they have to say, and yeah, like you said, shut up.
I think getting a job, set up the skill set is very important, but it is challenging as a because field is changing. Like there is a biostatistician, medical, someone in the ecology, and some other fields. So nature of data is changing all the time. And also the methodological change is happening. Now machine learning is coming. And technological advantage. So we used to desktop some these things of code. Now it's going to the cloud. So as a fresh background of statistician, so I think we can accommodate all of the skills. So do you think, how do you expect from statistical development and how to develop the skill?
So, what was the question?
Question is where you get the different skill?
Where do you get the different skills?
Yeah.
So how do you gain the vast variety of skill required from
I think as you progress in your career, you pick up skills, right? As I said, at the start, I didn't have my full history up there because I changed jobs almost every 2 years. It's just the sort of person I am. At the start, I was in accounting, and then I moved over to finance advising, as an analyst. From there, I became a business manager. And then I went back to finance. We got elected, and I was temporary government. Actually, QT in finance. So I needed some skills. I had skills there. Then I was senior program analyst. And now my title's data. I got to make up my title. You just pick up skills as you progress. And I found art, and I found about burger. It's just something I was interested in. You learn as you go along. And you should try and learn as you go along. I learned SQL. It's just something I needed for a program, needed for a sort of job on the side. And you start to pick it up. There's courses, a lot of them are free nowadays, especially in space. You learn it, and I've managed teams of 20 people. Managed to do now. It's stressful, it's enjoyable, but I'm not a good manager. My wife is a great manager. I once had 2 people who were arguing my $10, $20. He said, go to lunch and sort it out. That is actually a HR offence that I could have been before now, and I've learned by making mistakes and by doing things. No, one of them, John Miller gave me $20 back.
So I think also what needs to happen is expectations. Your understanding and progression is often incremental. Your career pathway is not usually linear. So I know for me, what I have realised is what I imagined myself doing 10 years ago is not what I'm doing now. So you can have all these career dreams, but what actually happens in real life determines your next step. If I don't have amazing, bioinformatics, I don't know bioinformatics, I'm a good biostatistician, general knowledge. If I want to develop in that area, I can't just go to be a senior bioinformatician. I have to actually go in at a junior level as a bioinformatician, but on a senior level as a biostatistician. So just understanding and setting expectations.
Also, what your career goals are changed. Like as I said, I worked in investment analyst, and that was loads of fun, and I really enjoyed it. You know, well compensated. And then I had a child. And now I earn less 8 years later on than I did back then. But I start work 9:30 to 2:30, 2 days a week, and I also work 1 day a week. And before I started this job, that's what I put in my contract. So this is what my main requirements are, because I want to do school, pick up and drop off, and I work 1 day a week. My goal isn't to earn money anymore. It's to have something I enjoy doing, but I want to do it well.
That's a very important point. Your family is part of your career. It's not something separate.
Actually, this is what somebody was talking about when we were not to do a PhD and the pressure for academia. The people who are all been telling you to do a PhD because the people who are lecturing us often are people who have got a PhD that have been in academia for decades. They existed in a period of history when, I'm sorry, they had wives who would drop everything and pick up and move across the world with them and take care of the family. So unless you are going to go and have a spout school, give up everything and follow in your career, it's going to be really hard in academia. And you will grow a massive beard while you wait for your
One thing to show you, what you don't want is to have two academics in the family. This is one of the nice things, at least about working with CSIRO, is if you work for an organisation that, you know, if your wife manages to find a job in the same country as you, you can actually relocate, right, to another office. I can do that, which is great. But yeah, I mean, it's a common joke that you know, the two body problem. It's like both finding jobs in the same place. And another consideration, I guess, is, you know, and again, this is going back to money, and I'm definitely not a person that says money is everything, but it does help. And it helps early on too, right? Like your earnings, you know, when you're young, you know, that kind of grows exponentially. You can afford to buy a house like we did when we were 25, not a house unit, but yeah, I mean, that's great. And you do sacrifice that by continuing to study. So, yeah, I think, you know, going to do a PhD and becoming a, you know, an academic or a research scientist is a bit like, you know, becoming a monk, growing a beard.
Well, I think there is a lot of opportunity with the master to work in research. The PhD is really if you want to be a group leader, a professor yourself. If you're interested by doing research in academia or the government with a master, there is a lot of opportunity now.
On that note, I think we probably need to wrap up, and I think there's pizza outside. I'd just like to say thank you to everyone who made this happen, especially for Carmen, who organised this whole event, and we really appreciate it. Again, so special and enjoying the whole lot. Thank you. There's bits for all of the presenters. So, Mark, do you want Yeah, we thank you very much. And please, think of becoming a study member as being coming to these events and being part of the community. And what's important is you might meet the future employees. It's really important. Thank you very much. Have a good day.
So you're on this